are.
We are scientists.
We are researchers.
We are mathematicians.
We are engineers.
We are women in engineering.
We are problem solvers.
We are
collaborators.
We are friends. We are competitors.
We are community.
We are diverse.
We are driven.
We are confident.
We are adventurous.
We are curious.
We are dreamers.
We are fun.
We are volunteers.
We are leaders.
We are entrepreneurs.
We are student athletes.
We are rocket scientists.
We are
engineers
snowboarders.
We are safe.
We are sweet.
We are ship.
We are She is Emmy.
We are Goldie-Craft.
We are resilient.
We are hopeful.
We are interdisciplinary.
We are inspiring.
We are CSE.
We are CSE.
We are CSE.
We are CSE.
We
Are
graduating.
Good afternoon, and welcome to the Spring 2021 graduation ceremony, both in person and remote. My name is Joseph Labus, Professor and Department Head for Civil, Environmental, and Geoengineering. Our name reflects our 3 degree programs, and our vision is inspired and innovative engineering for society. We are here to celebrate the achievements of our graduates, but first I'd like to provide some history of our department. In 1871, the Board of Regents voted to form a civil engineering program in response to the country's need for civil engineers to design and construct bridges, dams, roads, tunnels, and other infrastructure. The program steadily grew, and in 1910, the university established the Department of Civil Engineering. Some 70 years later, the newly constructed civil engineering building opened and received the Outstanding Achievement Award from the American Society of Civil Engineers for pioneering use of underground space. 95% of our building is underground. Although environmental engineering only became a degree program in 2014, work related to the environment has been part of the department since it was established. For example, in 1938, the first wastewater facility in Minnesota, the Pig's Eye Water Treatment Plant, was opened, and this facility saved our river. The chief engineer, an alumnus and eventual faculty member, helped establish the University of Minnesota as a world leader in environmental engineering. Today, students and faculty continue to solve problems in water quality, as well as pollutant fate and transport, groundwater remediation, stream restoration, and many other areas. The history of geoengineering dates back to 1888, when the School of Mines was established. In its glory days, the School of Mines offered degrees in mining, metallurgical, petroleum, and geoengineering. The School of Mines has a special place in the hearts of Minnesotans because in 1946, a process was discovered to change taconite rock into commercial iron ore. The School of Mines was disbanded in 1970, and geoengineering found a home in our department, with students and faculty advancing computational methods, drilling mechanics, hydraulic fracturing, just to name a few areas. Throughout the years, students, faculty have produced valuable work benefiting communities in Minnesota and beyond. I already mentioned our first water treatment facility and the taconite process. In addition, some of the world's largest dams have been designed and studied in our hydraulics laboratory. The new 35W bridge contains hundreds of sensors that monitor force, movement, and temperature, and this information is being used to analyze performance. Graduates in civil, environmental, and geoengineering, you will provide the bedrock on which our society will continue to flourish. Many challenges remain, and I look forward to your inspired and innovative engineering for society. It is now my privilege to introduce Professor and Dean of the College of Science and Engineering, Moss Cave. Since joining the Department of Electrical and Computer Engineering in 1975, Dean Cave has served in various leadership roles, including Department Head, Associate Dean, and for the past 3 years, Dean of the College. Dean Cave is hardly regarded for his research in signal processing, specifically in wireless communications. He is a fellow of the Institute of Electrical and Electronics Engineers and the American Association for the Advancement of Science, and he has received numerous professional awards. Please join me in welcoming Dean Moss Cave.
Well, thank you very much, Professor Labus. It's a true pleasure to be with you this afternoon. Hello, graduates. Congratulations. Congratulations on your commencement, civil, environmental, and geoengineering classes of 2021. You have achieved a tremendous feat. We know the dedication, self-discipline, and sacrifice required to normally earn a degree in the College of Science and Engineering. But these are not normal times, and you have graduated during a very difficult period. What this pandemic has reinforced, though, is the critical work of scientists and engineers. With your graduation from CSE, you're now among them. You are needed. Your contributions can make a big difference. The commencement is the college's happiest and most important occasion of the year. It is the symbol of accomplishment of you, the graduates, and a milestone as you move to the world beyond the university. It is a time to celebrate your achievement with your parents, family, and friends. I am very sorry that we're not able to be together in one ceremony as a CSE class of 2021, along with parents, family, friends, and many representatives of the faculty from the college. But please join me with a round of applause to thank all who have supported you during your time at the University of Minnesota. Although you're finishing one chapter of your life now, you're also just beginning another. Step into that new chapter boldly as you have faced this challenging past year. Many of you will enter the workforce at a very uncertain time, but don't forget, you're resilient, and as an engineer, you're a problem solver. At this critical moment in our country and in countries around the world, we need problem solvers. We need problem solvers like you who are resilient and can adapt and adjust on the fly, who can think and innovate in a crisis. On behalf of everyone in the College of Science and Engineering, I want you to know that we're so proud of your achievement. You are our next innovators, thought leaders, and entrepreneurs who will help us through this crisis and the next and many others to come. You're indeed our hope for a better future. I remind you that although as graduating seniors you have now been honored for your accomplishments and acknowledged as such, you do not officially have degrees yet. Only the Board of Regents has the authority to confirm degrees. I wish you all the best after graduation, and I hope you continue to stay engaged with us, your department, and your college. Congratulations, CEGE class of 2021. Stay strong, stay safe.
I'm proud to introduce our student speaker, a representative of the class of 2021. Grace Keller, a civil engineering major, will present her views on the challenges ahead. Please join me in welcoming Grace Keller.
Thanks, everyone. As civil, environmental, and geoengineering students, we have spent a generous portion of our college careers learning about stability. We may study ecological stability, define a stable structure, or perform a slope stability analysis on a dam. It's a bit ironic, isn't it, to study this concept so thoroughly when the world around us feels anything but stable. Amidst a fight against a deadly pandemic, systemic racism, and increased gun violence, we must also face an impending climate emergency and our nation's visibly crumbling infrastructure. As engineers, it is our responsibility to battle the latter two crises, but as humans, it is our duty to combat them all. This year, I have witnessed the students of CEGE confront these challenges. We are practicing sustainable living and educating ourselves and others about the climate crisis. We have worked for local municipalities, government agencies, and engineering firms that seek to safely transform vital infrastructure like roads, bridges, and the electric grid. We are learning about the injustices of this world and standing up for what is right. And we have now completed our engineering degrees from a distance to slow the spread of a deadly virus. These are no small feats. I'm immensely proud of each and every one of us. To be honest, it truly hasn't hit me that we're all about to become real engineers. Being an engineering student has become a prominent part of my identity for these past 4 years. It feels like just yesterday I was a first-year student hesitant to enter the civil engineering building out of fear of getting lost on one of its many underground levels. I already miss the late nights in the lounge where I studied so hard I lost track of time completely. Partially because the building's fluorescent lights and shortage of windows makes you feel a little bit like you're in the Twilight Zone. I have limitless positive experiences because of this department, my classes, and all of you, my classmates. It was impossible to walk into the civil engineering building without seeing a friendly face. I've come to realize that it truly is the people that make this profession so great. We are willingly diving headfirst into some of society's greatest challenges, tackling intense tasks to build critical infrastructure and daunting projects to remediate environments that humans have harmed and left behind. We are about to enter a profession of hard workers, ingenious thinkers, and above all, good people. And we are doing so with support for and from each other. The flexibility, care, and guidance from the faculty of this department has helped pave the way for the graduating class of 2021 to face these pressing challenges ahead of us. I will forever be grateful that the supports my classmates and I needed were there to help us stand tall. Yes, the world right now is especially unstable, but our time here at the University of Minnesota has made us strong. We can withstand whatever forces life applies and whatever loads we might have to carry. We are civil, environmental, and geoengineers after all. We battle instability every day. It has been my absolute honor to share the classroom with all of you. I cannot wait to see the amazing impact each of you will have on the world. Congratulations to the class of 2021. We did it. Thank you.
Thank you, Grace. You forgot your gift. It is now my privilege to introduce our distinguished guest speaker, Dr. Ellie Ling. Dr. Ling earned her Bachelor of Civil Engineering degree from the University of Minnesota in 2008. And some 13 years later, she's a professional environmental engineer at Barr Engineering, engaged in water and wastewater treatment and site remediation projects. Her work includes process modeling, bench and pilot testing, and preliminary design. She has also served as a technical advisor internally for projects related to water quality and statistical analyses. She works with clients in the power, mining, agricultural, manufacturing, and municipal sectors. Through her successful management of multi-organizational teams in complex projects and programs, Dr. Ling has become a leader in the environmental engineering community, and I am proud to say she's a member of the department's advisory board. Please join me in welcoming Dr. Ellie Ling.
You just graduated from college. Congratulations. Now, I know that I'm biased, but you are joining a great profession. It's easy to love what you do when you do something meaningful and challenging every day. Civil engineers build stuff that people need. Safety from the elements, clean water, ways to get places. And as civil engineers, you will never need to doubt your broader value to society. It's not always glamorous. I know, I'm a wastewater engineer. No one gets revved up to spend money taking care of their crap, literal or figurative. But modern society depends on us every moment of every day. Much like the infrastructure we build, you should strive to be resilient and reliable. Some of the techniques and methods in our business have been around for decades, but it's not all set in stone or concrete. There are plenty of exciting new challenges to be conquered in the near future, and you are the ones who get to do them. Your education thus far has prepared you for what you need to start changing the world. But your education will never be finished, and the way ahead may not always be clear. My second year of graduate school was really hard. I'd spent most of my adult life until then being pretty good at stuff and being generally afraid of messing up. Now I had a project that was poorly defined, and nobody could tell me the steps because nobody knew them. I struggled with what to do on a day-to-day basis. I spent months paralyzed by ambiguity, agonizing over the fact that I had no idea what to do. It took a lot of messing up before I started to feel comfortable with uncertainty. And sometimes that's what learning looks like. I polled some coworkers about their top tips for graduating seniors, and over half of them said the most important thing is to keep a growth mindset. A growth mindset is about asking questions and asking for help when you need it. It's about asking for feedback and having the courage to listen and change yourself for the better. It's about learning from those around you, and not just those with college degrees, but utility workers, contractors, community members. Give yourself the freedom to make mistakes, because that is when you will learn most. And your coworkers will catch your mistakes in your organization's well-defined review process before anything gets built. Come up with 10 ideas and scrap the 9 of them that won't work. This is where innovation comes from. Ultimately, a growth mindset is about humility, about never feeling like you have all the answers. In thinking back, a growth mindset is what I needed when I was so lost during grad school. I was too caught up in how I was feeling at the moment instead of focusing on the future and thinking about how to make progress and figure stuff out. I hear from other engineers that they struggle with this in their first 5 years in the workplace, grad school or no. These days, I oscillate between feeling amazing at my job and feeling like I'm in over my head. And I know that's normal too. With a growth mindset in mind, I want to share some ideas to help keep you making progress and moving forward, even when you feel like you have no idea what you're doing. The first step is to define the problem. When I dive into a new project, I like to think of where I'm starting as point A and the project goals as point B. The project is getting from point A to point B, and you have to understand both of them well to do a good job. Point A is the information you have or can get pretty easily. It might be traffic projections, existing site conditions. For me, point A is often how much water needs to be treated and what's in it. Point B can be a little bit more ambiguous. People often ask me, how do I treat this type of water? And my response is often, how clean does it need to be? Do you want to drink in it? Are you going to swim in it? Are you going to put it down the toilet? If I'm going to be drinking that water, I might run it through membranes and advanced oxidation to remove nearly all the contaminants. But if I'm going to be flushing it down the toilet and mixing it in with my poop, that would be a huge waste of energy and resources. Those are two very different projects. Sometimes you can't always see far ahead to know what the end of the project looks like, and that's okay too. Just set a point B somewhere in the future and make progress towards it. Once you get there, you can recalibrate. Once you know where you are and approximately where you're going, you can get started on the project, and that's the fun part. You know those multi-step exam problems where each part builds on the answers from the previous part? Real-world projects end up being something like that, except nobody's telling you the steps. In fact, no one's going to tell you the values you start with or how to get them. You get to figure those out too. But don't panic. This is the fun part. The key here is to break it down into manageable chunks and keep making progress. Even if you feel like you have no idea what you're doing, don't let it bog you down. Draft up some ideas for a first step and try something. It's probably not going to work. Try something different. Ask someone for advice. With each step, you learn from your mistakes. And with each step, you become a better engineer and you get closer to the project goals. This hasn't always been my favorite part. It's a skill that needs to be learned and practiced, just like anything else. You will discover that even if you can't see what the end goal is, you can usually find the next steps. You don't need to be confident in what you're doing at any given moment, but you can still be confident that you can figure it out. You just finished a huge accomplishment, and you're entering a profession that's in high demand. The American Society for Civil Engineers grades the state of our infrastructure as a C-. As some of you may know, a C- is the lowest passing grade. Wastewater gets a D+, which is slightly better than our roads at a D. Much of this is the result of decreased public awareness and public funding. But infrastructure supports every aspect of our society. If we want things to continue to function, the next few decades are going to require a lot of catch-up to rehabilitate our infrastructure for future generations. This is where you come in. Your generation of engineers will need different skills than the engineers that are retiring today. You will need different skills than me. Some of these skills have not been defined yet. You will need to adapt and learn quickly as technologies and techniques evolve. You will need to communicate more effectively and more frequently. It's going to be great. Don't worry about being wrong now and then, and be ready to change your mind when you learn something new. It's okay to feel like you don't know what you're doing. It's more important to get it right in the end than to be right at any given moment. This class will go on to do great things. You are tomorrow's superheroes. It's been my honor to speak to you today. Congrats again on your graduation.
Thank you.
The next part of the ceremony involves awards, a faculty award, the best instructor, decided by the students, and the Outstanding Student Award, named the Simon and Claire Benson Award, decided by the faculty. To present the Faculty Award, I am delighted to introduce Renee Saylor, a civil engineering major and the president of the American Society of Civil Engineers Student Chapter, which is celebrating its 100-year anniversary, hopefully with an in-person event in the fall. Renee?
Hello, everyone. The BRA Faculty Award is an opportunity to recognize an individual faculty member who demonstrates interest in and a commitment to undergraduate students and the undergraduate program in civil, environmental, and geoengineering. At the end of each semester, the CEG undergraduate students cast their votes for this award based on criteria including excellence in teaching, advising, mentoring students, and the faculty members' general involvement in undergraduate activities in the department. I think we can all agree that this year's recipient of the BRA Award is well deserving of this recognition. Students feel that she truly cares about them and will go out of her way to help them succeed. Additionally, during this past year of the pandemic, she was able to adjust her teaching to the virtual format effectively, which made a difficult time easier on her students. Overall, this year's award recipient is a fantastic teacher who I'm sure has made an impact on many of us who are here today. Please join me in congratulating the 2020 BRA Undergraduate Faculty Award winner, Professor Lauren Linderman. Congratulations.
To present the Student Award, it's my pleasure to introduce my colleague, Professor Stefano Gonella, Chair of the Awards Committee. Stefano?
Good afternoon. My name is Stefano Gonella. I'm an associate professor in the Department of Civil, Environmental, and Geoengineering, and I'm also the chair of the awards committee, whose task is to identify the recipients of our departmental student awards. The committee is composed of myself, Professor Jialiang La, and Professor Michele Guala, and I would like to take this opportunity to thank both of them for their great work and help throughout the process. Every year we receive nominations from the faculty, and based on this input, we interview a selected group of students. Since many of these students are seniors, these interviews give us one last opportunity to meet and interact with them and give them a sort of farewell as they are about to step into the next chapters of their professional or academic lives. Perhaps the most important of the committee's task is to select the recipient of the Simon and Claire Benson Award. And today I have the pleasure to announce the winner for 2021. But before I do that, let me share with you a few details about the purpose and history of the award. I'm going to quote a little excerpt from the official bylaws of the award. Quote, "The Simon and Claire Benson Award is presented annually to a civil, environmental, or geoengineering student whose performance is judged to be outstanding in a manner that exceeds academic achievement alone. Typical considerations for this citation are outstanding research, leadership, oral presentation, and effort or improvement." In 1986, the civil engineering faculty voted to designate the former CE citation for outstanding undergraduate performance as the Simon and Claire Benson Award, in memory of two former outstanding civil engineering undergraduates of the department, brother and sister, who were tragically killed in a car accident in August of 1986. Claire was a recipient of the award in 1985. Simon graduated 1 year before the award was instituted, but would have been a worthy recipient. End quote. This award is the highest honor bestowed on a student by the faculty of the Department of Civil, Environmental, and Geoengineering. So in essence, I like to say that with this award, we accomplish two objectives simultaneously. On one end, we recognize the most outstanding student of the graduating class, and at the same time, we remember two alumni of the department who unfortunately are not among us anymore, but who have left a long-lasting and inspirational legacy. So like every year this spring, we had the pleasure to interview a number of highly deserving candidates, but one name clearly emerged from the pack, and the committee was unanimous. The winner of this year's award is graduating with a degree in civil engineering. He has excelled in the classroom throughout his 4 years in the program, as indicated by his outstanding, nearly perfect GPA. He has challenged himself with an impressive array of technical electives, including challenging PhD-level courses, consistently impressing all his instructors with his performance, and more importantly, with the level of interest and engagement that he has shown. Since his sophomore year, he has been heavily involved with undergraduate research, leading 2 research projects in the area of mechanics of architected materials. His research has resulted in a first authorship on a journal paper, a co-authorship on a provisional patent, a conference presentation, and leadership roles with the organization of outreach activities. This is truly a remarkable set of accomplishments, and not only for an undergraduate student, but for any researcher. I've had the pleasure of serving as his research advisor throughout these efforts, and I have witnessed directly these impressive qualities, which include tremendous resourcefulness, uncommon independent thinking, and remarkable professional maturity. In 2020, his academic achievements earned him a prestigious astronaut scholarship given by the Astronaut Scholarship Foundation. Over the year, he has developed interest in mechanics and modeling, nurtured in our department through courses such as thermopore elasticity and rock mechanics, where he was heavily inspired by the style and mentoring of Professor de Tournay. Next year, this interest will take him to MIT, where he will pursue a PhD in the area of mechanics of granular media, hoping to become one day a university professor. So without further ado, the recipient of the 2021 Simon and Claire Benson Award is Mr. William Zunker. Congratulations, Will, and best of luck for all your future endeavors. Thank you.
The graduates will now accept the obligation to the Order of the Engineer. Graduates, at the end of the oath called the obligation, place the engineer's ring on the little finger of your working hand. Typically, this is done by a delegate by you sticking your hand through our ceremonial ring, but because of the pandemic, you will place the ring on your own finger. When you are called to the stage to be recognized as a graduate of the University of Minnesota, you may place your hand through our ceremonial ring, which was fabricated from steel obtained from the 2007 collapse of the original 35W bridge. Catherine French, Distinguished Professor of the College of Science and Engineering and Delegate for the Order, will lead the ceremony. Kathy?
Thank you, Joe. It's my privilege to be here today, and on behalf of the other faculty that are here, this is our favorite time of year to see you off, and we're so grateful to be able to see those of you here in the presence, to see you off in person. It's my privilege on behalf of the National Board of Governors of the Order of the Engineer to preside and to lead the ceremony. So first, a little bit of history about the Order of the Engineer. This ceremony presents an opportunity for us to take a pledge and to recall that the professional purpose of engineering involves the pursuit of a learned art in the spirit of public service. By following the acceptance of the obligation, The individual engineer reinforces similar efforts of his or her peers, realizing in unity there is strength. Decades ago, our engineering counterparts in Canada had the same feeling. They believed that a need existed for the introduction of a spirit of cohesiveness among engineers. The Canadians believed that a good way to achieve this purpose would be to instill in engineers a consciousness of belonging to one another, to themselves as individuals, and to those whom they served. This was done in 1926 in Canada in what is now known as the ritual of the calling of an engineer. The words of the ritual were written by the English author Rudyard Kipling. He had a much depth of feeling for engineers as builders of things intended to benefit mankind. In Ohio, the idea of similar maxims to those were well established, and in 1966, a group of engineers in Ohio, with members of several engineering organizations, began to pursue the objective of what came to be called the Order of the Engineer. Seniors of Fenn College of Engineering of Cleveland State University, counseled by their dean, designed and held a ring ceremony, and the first reception was on June 4th of 1970. Since then, the movement has spread rapidly through the states. It's patterned on the Canadian concept, but with a stainless steel ring symbolizing the strength and unity of the profession and providing an identifying mark of an engineer. A little bit about the significance of the order. The Order of the Engineer, to which you will soon belong, is an independent organization. The purpose is to foster a feeling of pride and dedication to that profession which binds us together. You are asked to accept with pride the meaning of the ceremony to which you are about to subscribe. The obligation should be freely given and the responsibility gladly accepted. The order is symbolized by the acceptance of an obligation and the wearing of the stainless steel ring. The obligation is the formal statement of an engineer's responsibilities to the public and to the profession. It's a creed similar to the Hippocratic Oath, commonly taken by med school grads, which sets forth an ethical code. The obligation likewise contains parts of canons of ethics of major engineering societies. Initiates, as they voluntarily accept it, pledge to uphold the standards and dignity of the engineering profession and to serve humanity by making the best use of Earth's precious and limited resources. The obligation is a composite of several creeds. It emphasizes the fact that we as engineers have certain obligations. It promotes honesty, integrity, and recognizes that today's engineers are dependent on their predecessors for their skills. The significance of the ring, it's a symbol of pride, prestige, honor, and professionalism among all engineering in the United States. It serves as a reminder to the engineer of our obligation to society. The symbol of your desire to serve the public is the engineer's ring. The ring that you'll wear on the fifth finger of your working hand will also say to all who see it, here is an engineer, possessed of a publicly avowed dedication to the profession and the public to which we serve. Will all the candidates for induction into the Order of the Engineer please stand? And will all current members of the Order of the Engineer please stand? So we'll now go over the acceptance of the obligation. In a few minutes, I'll ask you to raise your right hand and recite with me. Candidates for the Order of the Engineer, as I mentioned, is an independent movement. The purpose is to foster a feeling of pride in and dedication to our profession. Your membership in the Order is symbolized by the acceptance of the obligation and your wearing of the stainless steel ring on your working hand. There are no meetings other than the ceremony, and there are no dues. So please raise your right hand and recite with me the obligation of an engineer. I am an engineer. In my profession, I take deep pride. To it, I owe solemn obligations. As an engineer, I pledge to practice integrity and fair dealing, tolerance and respect, and to uphold devotion to the standards and the dignity of my profession, conscious always that my skill carries with it the obligation to serve humanity by making the best use of Earth's precious wealth. As an engineer, I shall participate in none but honest enterprises. When needed, my skill and knowledge shall be given without reservation for the public good. In the performance of duty and in fidelity to my profession, I shall give the utmost. You may now place your ring on the small finger of your working hand as the outward sign of our profession. And I welcome each of you to the privileges and obligations to the Order of the Engineer. Again, the ring is a reminder of our calling. The certificate that you've signed is your creed. It bears your name and your signature. It's your pact with the profession. Read it thoughtfully. Regard it with humility. Wear your ring proudly and with distinction, for you are an engineer. I ask the audience to join me in congratulating the newest members of the Order of the Engineer.
You could sit down. Now for the main part of the ceremony, the recognition of our graduates. Professor Aaron Serto, Director of Undergraduate Studies for Environmental Engineering, will announce your names. As you are escorted by your row to cross the stage, please maintain 6 feet of distance between you and the next student by using the floor markers as guides. Your mask should be worn at all times. When you reach the first table, place your name card face up on the table for Professor Serto to read. As you get on stage, your name will be read. Please stand on the X, face the crowd as your photo will be taken. Then you may leave the stage. Volunteers will direct you to your seats. Dean Cave, if you would join us on stage. Professor Serto.
Lydia Willamitis. Grace Ann Keller. Renee Saylor. Dominic DeVita. Zachary Heipel. Mason Balster. Benjamin Veggie. Kurt Krautman. Haley Keekley. Braden Jerstad. Laura Lewis. Jared Voigt. Peter Olson. Evan Eppel. Peter Ferguson. Shugri Ahmed. Christina Brierly. Sheridan Henderson. Henry Meeker. Martin Ramaswamy. Nina Miskowski. Kyle Weisshahn. Isaiah Stieber. Rauf Abidi. Blake Ondert. Abigail Dessa. Wyatt Fitzsimmons. Maddie Kappenman. Thomas Holmes. Freddie Fernandez. Daniel Belinsky. Fadila Zidnati. Redmond Wallace. Benjamin Ontel. Carl Lind. Tomas Migueles. Megan McDevitt. Jared Juth. Yvonne Contreras Dalal. Stanley Anchita. Dean Deneen. Austin Phillips. Joey Obedinsky. Kelsey Fisher. Josiah Ferguson. Michael Odell. Joseph Reif. Now I'd like to direct your attention to the screens so we can recognize our graduates participating virtually. Gaith Al-Siabi, Zach Baker, Caleb Bralsma, Ryan Gottsleben, Wei Fung Nguyen, Noah Quiring, Rachel Schnell. Yu Ping Wu. William Zunker. Anne Doolin. Christian Swenson.
I now invite Professor Paul Strakowski, Associate Dean for Undergraduate Programs, to say a few words. Paul?
I want to thank the Civil, Environmental, and Geoengineering Department for inviting me. While I'm a mechanical engineering professor, I'm also your associate dean, and I welcomed many of you some years ago during Welcome Week. We played a fun game, Want to Be a Millionaire. Many of you did all right. I've also welcomed many of you since then as transfer students, and it's a great honor to be here. Grace, I share your description of your building, but as a mechanical engineer, it scares me to death. But I do know that and you spoke of it well, students in this department are very close. And I sometimes go downstairs to your study space and see you engaged in deep conversation. It's your place to be. So most of my colleagues know me as a man of levity, but it's been one of those years. And so I decided to be a bit more philosophical today. So some thoughts. I begin my remarks sharing thoughts from a novel I recently finished called The Four Winds. In this part of the world, the winds are predominantly from the west. In the winter, they come from the north-northwest, shifting to the west in the spring and to the west-southwest in the summer, moving again to the west as the earth transitions from fall to winter. As the earth completes its track around the sun, a process so embedded in our lives so as to proceed largely unnoticed. The novel, The Four Winds, is historical fiction surrounding the 1930s in the Central Plains of the United States. The Great Depression, the Dust Bowl, poverty, starvation, and stories highlighting how Americans didn't treat each other as they wished to be treated. The 1930s were very difficult years. The book describes these challenges through the lives of a single family as they migrate from the Texas Panhandle to California, surviving, sometimes just barely. But the message was overwhelmingly positive and forward-looking. The winds of change in that time were the four winds. The winds came from the north, south, east, and west, bringing with them new opportunities to grow the human spirit. Your time at the university also carried the four winds, particularly so these last 12 months, when challenges came in many forms and from all directions. Some days, perhaps you felt isolated, but other days you realized you could solve some of society's most challenging problems, lead with a renewed sense of strength, or develop new ways of understanding yourself and how you would fit into our world. Some days, if you were like me, you took 2 steps backward. But on others, you completed a race so exhilarating as to sustain you to this day as you walk across the stage and become a graduate of this great institution. You didn't just survive the westerly winds of the upper Midwest. You conquered the four winds. You see, the four winds have helped you form into the scholar, leader, builder, designer, and collaborator that you are today. No one can take the badge of 2020-21 away from you. It has given you an opportunity to see yourself in new ways, stripping away veneers that other generations didn't have to strip away. My parents were from the so-called greatest generation. I subsequently was born as a baby boomer. And now we have new and equally unfair buckets into which you are placed. Millennials, Gen X, Gen Y, Gen Z, I can't keep up. There never ever was a single greatest generation. Within every generation is greatness. I stand before you today humbled by what you've accomplished. Within this room will be the next great generation. Do not be defined by labels. You have achieved so much in your young lives and have developed perhaps a perspective uniquely created by the challenges and opportunities these past 12 months when the winds indeed came from every direction. My father told me once when I was about your age, he said, Paul, when you're old and you leave this earth, you will be wise. You'll have figured out who you are and why you were meant to walk this planet. And then he smiled and looked at me and said, well, Paul, the key, however, to life is to get wise before you get old. You've embarked on a journey through the College of Science and Engineering that brings you to this stage today with friends for life, with a belief in yourself, fortified by the challenges of the four winds. And you are wise. More than you know. The challenges you have faced these last 12 months have certainly changed you. You can't put them under a rug, but don't ever let them define you. Remember, as you walk, the four winds will not always be at your back, but when you face the winds head on, you breathe them in. They will empower you and provide the wisdom that only that can provide. Congratulations on your remarkable achievements.
Okay, my last set of instructions. You will be dismissed by rows, and we will exit out the Oak Street doors. Volunteers will help direct you. Of course, this is a time to celebrate, but please do not congregate outside of the plaza nor near the McNamara entrance, as staff must prepare for the next ceremony. So go to the Civil Engineering Building, the courtyard. So in closing, graduates with Bachelor of Engineering degrees from the University of Minnesota, you are recognized as individuals of high ability and intellect. However, I leave you with a quote from a famous fictional professor. It is our choices that show what we truly are, far more than our abilities. Graduates, congratulations on your achievements, and make good choices. Class of 2021, dismissed. Go Gophers.